Let's learn about the quicksort algorithm. So quicksort, it is a divide and conquer algorithm, and it is a very famous sorting algorithm. What we have to do is firstly we have to pick a pivot from the array that we are given. We have to pick an element, and we are going to compare all the different elements of that array with that single element. The elements which are smaller to the pivot element, they will be placed first, and the elements which are greater than the pivot element, they will be placed after the pivot element. Okay, so the pivot element will be placed then at its correct position, where all the elements which are smaller than this are placed before, and all the elements which are bigger than the pivot element, they are placed after. So if we do this for every single element, that meaning if we put every single element on its correct position, and for every single element we have all the elements that are smaller than the element before and all the elements which are greater than that particular element after, then that means the array will be sorted, right? As simple as that. So what we will be doing is, yes, as I said earlier, we are going to partition the array. We are find a pivot element that will be according to our choice. We can either choose the first, last, or any random pivot element. But for our solution, we are going to always select the first element from the given subarray uh, as the pivot element, right? So we are going to move all the elements before uh, which are greater to the right, and all the elements which are smaller on the right side to the left, right? So the smaller ones are on the left and the greater ones are on the right. And how we are going to do this is basically we are going to use the two pointer approach. We are going to have two different pointers. One will be starting from the start of that particular subarray, and the second pointer will be starting from the end, right? So that we can always swap two different elements. These two different elements are going to be the element from the left pointer is going to be the one which is greater than the pivot element, and it comes in the left, right? And the element that we want to swap from the other pointer is basically the element which is smaller than the pivot element, but since it is on the right, therefore we will swap these two different elements, and we are going to recursively do this for the left and the right part. Meaning once we are done with this placing the pivot on its correct position, then we know that the pivot is on its correct position. Then we are going to do this for the left subarray, and we are going to do this for the right subarray recursively. And since we are dividing the whole array into three different elements, the one is the pivot element, the first one, and the one is the left subarray, and the right one is the right subarray. Therefore, it is a divide and conquer algorithm, because the solution or the input size is getting divided into different components. Okay, so let me do a dry run. So we are always selecting the first element. So initially we are given this array 5, 1, 4, 2, 8. Now we are selecting 5 as the pivot. For our firstly given array, we have the start at 5 and end at 8. Okay, so we are selecting the 5 as the pivot element. Now what we are going to do is that we are checking 1, 4, 2. These are the elements which are actually smaller than 5. Therefore, they should come before. And 8, since it is greater, it should come after 5. So when we do the partition, what we will do, we will place then 5 at its correct position. So 1, 4, 2 will come before and it will come after. And how this will be done? How 1, 4, 2 will come before 5 and it will go after is basically we are going to swap these elements using the two pointer approach. We are going to have a pointer starting from the left side, and then we will be checking that while the element is smaller than the pivot element, which is basically 5, now we are going to move forward. So 1 is already smaller, 4 is smaller, and then 2 is also smaller, right? So we are going to move forward, and then we are going to since these are the smaller elements, we are not going to do anything. But finally, when we are going to have another pointer which will be coming from the right side, and that will be always looking for elements which are actually smaller than 5. So which are or smaller than 5, but 8 is greater than 5, right? So the pointer from the right will see that 8 is greater than 5, but when it will come to 2, it will realize that 2 is actually smaller than 5, right? So the pointer that will be coming from the right side will be at 2, and the pointer that is coming from the left is moving forward, since these elements are smaller, and that is at 8, right? But since these two pointers, they have crossed their path, the pointer that is coming from the left is now at 8 and the pointer that is coming from the right is at 2. Therefore we will not do swapping, right? Because we have iterated through all the elements, and what will be done finally is that we will at the end, when we are done with these two pointers traversing through the array, at the end what we are going to do is actually we are going to replace the pivot element with the element uh, which is at the pointer location that is coming from the right, right? Because the pointer that is coming from the right is at the position where this element should be, right? The pointer is initially at 8 and it checks that 8 is actually greater than 5, so it should not be here, but the pointer comes here, and then here it can see that 2, it is actually smaller than 5, therefore it should not be over here. So we will actually replace this 5 to this position and 2 will come here, and therefore this is going to be like this 14258. Okay, so now we are left with two parts. 58 as its current position, therefore we have 142 in the beginning and 8 in the end, right? So from the left sorted path, now we are going to apply the quick sort on this one particular path, which is 142. Here we are selecting 1 as the pivot element. Now similarly we can see that 4 and 2, they are greater than 1, therefore they will be at their right side, and since there is nothing which is smaller than 1, therefore the left part is going to be empty array, right? So we already know that in an empty array or an array with element with a single element is already sorted, right? So therefore we don't have to do anything for the left part, but now we will now go to the right part. Okay, so the right part is actually 4 and 2. Now what we are going to do is we are going to take 4 as the pivot element, and then we are going to have two different pointers, right? The first one will start looking from the left side and the second pointer will start looking from the right side. So the first pointer that is going to be start looking from the left side will see that 4, is it greater than 4? No, 4 is not greater than 4, but 2, is it greater than 4? Yes, that means it is not its correct position. And the pointer that will be coming from the right will see that this element is not we are from the pointer that is coming from the right is actually looking for the elements which are smaller, right? So 2 is actually indeed smaller than the 4, therefore we will be what we will be doing is we will be swapping these two different elements, right? So the 2 will come before and the 4 will get to its position. So the final updated array would look like this 1 2 4, right? So this part 142, it is already sorted now into, and the left part, which is actually and the left part which is a single element, that is 8, is already sorted, right? So we will combine these two different arrays, which is 1 2 4 and 8. 5 is already at its correct position from which we did in the step 1, that is the right pivot position. So now the array will become 1 2 4 5 8. Now the final algorithm is like this. Okay, so let's solve this problem. Okay, so let's just call the method as quick sort. Okay, now we have the nums array given and we want two things, low and high pointers, right? So because we will be what we will do is we will be using low and high pointers to define our subarray. Okay, so initially what we are going to do is we are going to call the quick sort algorithm on the whole array. Okay, so for the whole array the endpoints are going to be 0 and length of nums minus 1. Okay, and this quick sort algorithm, so if start is going to be equal less than, or if it is start is greater than equals to and, meaning there is only one element or there is empty array, then we have to return. We don't have to do anything. Otherwise what we are going to do is basically we are going to find the we are set the pivot element. We are going to set the pivot element. No, actually, what we are going to do is basically we are going to partition this into two different parts. Okay, so the partition index is basically we will be getting from another method. Let me define that method as a partition. Okay, so this is another method. What it will do is basically it will partition the array into two different parts, and it is going to return the index of the point on which they are separating, right? So therefore we can have two different parts. So this is basically going to return the index of the pivot element, the partition element, right? So the partition, or we can say pivot index, is going to be called from self dot partition, and here we're going to provide the nums and low and high, right? So it is going to sort the elements in this partition such that the pivot element is at its correct position. All the smaller elements are on the left, and the greater elements are on the right, and also it is going to return the index of the pivot element. So we also have to now sort all the elements which are before the pivot element. Okay, so it is going to, we are going to call the same method for the nums, but this time the endpoints are going to be low and the pivot index -1. Okay, so this is for sorting the left sub array, and now we are going to also sort the right sub array. So the right sub array, for the right sub array, the endpoints are going to be pivot index +1 to high. Okay, so now what the partition is going to do, it is going to have the nums array and low and high endpoint. Always we are selecting the first element of the sub array as the pivot element. Okay, so let's select the pivot as nums of low. Now what we are going to do is we are going to take two pointers. One will be coming from the left and one is going to be coming from the right. From the left, we are always looking for the elements which are actually greater than the pivot element, for which are greater than the pivot element, right? So I is basically low and j is basically high. So while I is less than j, what we are going to do is basically while the elements which are on the left side, they are smaller or equals to the pivot element, we don't have any issue because the elements which are smaller should be on the left. Therefore we are going to move forward. And similarly on the right side, what we are going to do, while the current element pointed by the pointer j is greater than it is actually greater than equals to the pivot element, we are just going to move to the left. So this is what we are going to do. And now what we are going to do is, if the I is less than j, that means that if the two pointers have not crossed their path, meaning we have found a place where the left element is actually greater than the pivot element, and we will also find that the right element which is pointed by the j pointer is actually smaller than the pivot element, then we are going to swap these two different elements, right? So actually I made a mistake over here. This is I. So we are going to swap those two different elements. So nums of I and nums of j, they are going to be uh, swapped. We are doing this so that the element of which are greater should come on the left side, would come on the right side from the left, and the elements which are smaller on the right side should come to the left. Okay, so this is what we are going to do, and the elements are swapped. And finally what we are going to do is now finally we ha have to apply actually two different constraints also. Since I should not cross the sub array, therefore we have to put this I is less than n. We are not doing I less than equals to n because this is always incrementing I by 1. So if it is I is less than equals to n, that means I plus 1 is going to be more than n. I plus 1 is going to be n plus 1, and n plus 1 means we are out of array. So we are going to iterate through I less than n. And similarly here we are going to be j greater than start. Okay, so finally, when we are done with all of this swapping, then what we are going to do is we are going to position the pivot at its correct position, right? So pivot, which is basically the nums of low, is going to be swapped with nums of j, nums of j and nums of low. Okay, so this swapping should be done, and finally what we are going to do is we are going to return j, since j is now on the correct position where we have the pivot element. Okay, so now the partition algorithm is done. Self.partition, here we have to do self.quicksort, and then what we are going to do is that basically we are going to call the self.quicksort over here. All right, let's run this algorithm. If start is less than equals to end, so did a mistake here. We are using low and high instead of start and low, so let's just make it consistent. So let's make the naming consistent. Okay, here we are doing this, and and is not defined, so shouldn't have done this. And is high and low is same as start. Okay, so here we again have low, which is basically okay, so now we are using low. No issue. Okay, let's run this code. Wrong answer, null, because once again I forgot to return the nums. Now the solution is selected. Let me submit the solution. Now we are actually using recursion in this particular problem. Therefore, we are consuming some stack space, right? The stack space is getting consumed, but here we are getting the time limit exceeded error once again, right? The issue why this algorithm is not passing is because in the worst case scenario, the quick sort algorithm, it takes big O and square time complexity, and that is why this problem is not getting passed. The such problem occurs when you are making constant wrong assumption about selecting the pivot. You are already selecting a pivot element which is at its correct position. For example, let's say if we have an array that is actually how we are always selecting the first element, and if the first element is already at its correct position, meaning the array is already sorted, and in that case we will be uh, getting this issue, right? So the quick sort, in the worst case, it is going to be giving big O and square time complexity, and therefore this algorithm is not passing. But the solution, it is correct for quick sort algorithm. And since we are not using any extra space, we are doing in place sorting in the array. The space complexity is big O of 1. There is no heap memory getting used. We only have the stack memory that is getting used because of recursion. Okay.